Hello guys, this is Jimmy from Case Group, and in this short demo we're going to check out one of the new features in vray 2.0. As you probably know, when a ray of light passes through a refractive object, the light is dispersed into its basic components and we can see some interesting colors in the caustics. Well, in vray 2.0 we have actually updated the vray material to support that effect. If we open the material editor and select a standard vray material, you will see now that in the refraction section we have two new options. A checkbox that allows me to enable and disable the dispersion, and a parameter called ABI. We can actually use this value to control the amount of the dispersion we are going to see. If I increase this parameter, the dispersion will be less visible and it will be narrowed down, and if I decrease it, I'll actually spread it out more than natural. If I leave this parameter to its default value, I will create the physically accurate amount of dispersion based on the index of refraction. Now let's open a couple of scenes and see the different effects we can create using these two new options. In this simple scene, we are trying to recreate the effect of water creating caustics on the bottom of a small pond. If we take a look at the scene, you'll see that it's pretty straightforward. We have two objects, one for the bottom of the lake and another one for the water, and as you can see we have some animated displacement on the water surface. We're also illuminating this whole scene with the help of the vray sun, and we're looking or rendering the scene through a vray physical camera. Other than that, we're going to check out the indirect illumination and you'll see that we have actually enabled the caustics. Let's quickly take a look at the two materials. We have a standard diffuse material for the bottom of the pond, and we have just mapped its diffuse color. And for the water, we have the standard setup for water. Perfectly white reflection with Fresnel reflections, perfectly white refractions with index of refraction set to 1.33. And if we take a look, we have actually right now disabled the dispersion. So let's render out the image. We'll first build the caustics photon map. And then when we render the image, you'll see that we have completely white caustics. Now let's enable the dispersion, and you'll see that actually I have increased the ABI parameter, which makes the dispersion effect more narrow and less visible. But still, let's render with these settings. And again, we'll have to build the caustics photon map, which takes a couple of seconds. And now we will render the new image. As you can see, now the caustics are becoming more colorful and we can see the actual dispersion effect. Another thing that you should notice is that this takes really quickly to render, so we can very quickly render the whole animation and see the result. Let's wait for this image to render entirely and then we'll check out the animation. In this scene, I have created a little bit more complex setup. I have the refractive object in the middle. I also have a direct light for a light source, and I have a couple of cameras for two different points of view. I'm also animating the direct light. If we check the material, you'll see a similar setup. I have enabled the dispersion, but this time I'm actually decreasing the ABI parameter in order to have a more spread out dispersion. The difference in this case is that I have something in the environment, and I have actually added two atmospheric effects. A vray environment fog because I want to actually create volumetric caustics, and a vray tune because I want to be able to see the edges of the pyramid. Before rendering, I'll just adjust the light source in the scene and make it narrower. I'll hit render, and first we'll create the caustics photon map, which will take a couple of seconds, and then we'll be able to see the final render. As you can see, it took us 13 seconds to actually create a perfect volumetric caustics. And let's render from the other camera. Again, we will first build the photon caustics map and then render the whole image. Now, let's quickly look at the whole animation. This concludes our short demonstration. I am Dimitar Kristev Jimmy, and I thank you for watching.